Okay, hello, my name is Guillermo H and we're gonna start with the workshop number 8 is for various methods of solid meshing, creating a solid log. And the workshop objectives is to become familiar with creating a hex and a TET mesh for this workshop. Four models of the same system are gonna be created: a hex 8, a hex 20, a TET 4, and a TET 10 element model is to be created. This involves creating geometry from which the meshes are created. The same constraints are applied, loading are used for each model. The results for a linear statistic analysis for each model are compared. Okay, now for starting this, we're gonna have to create the 3D log. We're gonna go first, start open a new file. I'm gonna save it here. We're gonna name it log. Since I have already a log document, I'm gonna name it log the one. Okay, we're gonna leave this as it is. We're gonna click OK. Now for this, you must have the files from the workshop. So we're gonna go to File, Import, and import the already made 3D model, which is log. It's an XMT model. Gonna hit apply. This window is gonna pop up. I'm gonna click OK, and now we see our model. Okay, now we're gonna rename the default group as hex 8. We're gonna go to group, modify, and we're gonna click rename. This window is gonna pop up, and we're gonna rename it as hex 8. Wait, sorry, hex 8. We're gonna click OK. Okay, now we're gonna create points for the plane for creating some planes. We're gonna go to geometry, create point, and extract. We're gonna select here curve. Our parametric position is gonna be 0.5. We're gonna turn off auto execute. Always turn off auto execute before you start some activity. And we're gonna select multiple lines. So we're gonna use this icon, the plus icon, to add different selections at the same time. You're gonna select this curve, this one, and this one. These three lines or curves are gonna be selected. We're gonna click apply, and now we have created points in between the middle of those lines. Okay, now that we made that, now we're gonna create some planes so we can divide the solid, and we're gonna go to create plane and 3-point. Okay, now we're gonna select, we're gonna make two planes. The first plane, we're gonna select these 3 points, the one that we just made. We're gonna click, okay, the planes already made. Always turn auto execute off if you don't want this to happen to you. The next plane, we're gonna select these 3 points. We're gonna click apply, and our plane is created. Now we're gonna break our solid in these planes. We're gonna go to edit, solid, and break. Turn auto execute off, and we have to be click on delete original solids. This has to be checked. Solid list, check the whole solid, and breakpoint list. We're gonna click on our planes. Okay, now change this option to plane. Select auto execute off. Select the solid and select both planes. We're gonna click apply, and this message is gonna appear, and select yes for all. Now for the next break, we're gonna select both of the solids, and we're gonna select a different the next plane. Choose plane 1, and click apply. Yes for all. And now we have 4 solids. Okay, now that we made that, we're gonna create group TET4 and copy the geometry of this one to the next. We're gonna go to group, create. We're gonna enter a group name. We're gonna name it TET4, TET4. We're gonna click apply and cancel. Now we're gonna go to geometry, translate and solid and transform solid and translate. Okay. We're gonna move this direction vector. We're gonna put 0 space minus 10 space 0, leaving everything as it is. Turn auto execute off, and we're gonna choose all of our solids. Use the plus sign to select all at the same time. One, two, three, and 4. Okay. All of the solids are selected. I'm gonna click apply, and a copy of the solids are being made. Now we're gonna create the next group. We're gonna group create. We're gonna name it TET10. We're gonna click apply. We're going to return to geometry, and we're gonna do the same thing, but changing here our direction vector to 15. We're gonna use the same solids, so we only get to click apply, and now we created the next 4 solids. In the front view, we must see something like this. These are hex 8, or TET4, and our TET10. Now we're gonna post only our group hex 8. We're gonna go to group, post, and we're gonna select 8, click apply, and the other ones are gonna be gone for our site, but they're still there. I'm gonna click ISO view 1. Now we gonna create more points so we can break down to different planes to create hex 8, no, hex 20, sorry. We're gonna go to create the same in geometry, create point, and extract. Leave this one the curve, the value of 0.5, and we're gonna select 5 different curves. Turn out execute off. Since we're gonna select multiple lines at selection, we're gonna select these curves: 1, 2, 3, 4, and this line 5. We're gonna click apply. This is gonna appear. We're gonna yes for all. Okay, seems that we didn't make this point. Yeah, we didn't make this line here a point. We're gonna just select it, erase this, select and apply. Yeah, we got a point now. Okay, now that we already made the points, we're gonna create the planes for it to break. Excuse me, we are missing one more point, the middle point in the middle of the log. So we're gonna go to geometry, still point and arc center, and auto execute off. We're gonna choose 2 arcs, which are gonna be these both lines, arcs, and I click apply, and both lines are made in the center of the radius. Okay, now that we've done that, we're gonna break the planes with using those lines. Geometry, create, sorry, plane, and 3 points. We'll be using the first plane. We'll use these 3 lines. These 3 points. Sorry, 1, 2, and 3. So I missed one. Okay, yeah, these 3 lines. We're gonna click apply. So a plane is made. We're gonna click this now. This point, and this point. We're gonna click apply. Our plane is created. Now that we made these 2 planes, we're gonna break our solid again. So we're gonna go to edit, still in geometry, solid and break. The solids we're gonna use are different. So for this one, we're gonna solid list. We're gonna select this one and this plane. We're gonna click apply. Now it's created. Message is gonna appear. Yes for all. The next solid we're gonna use is this solid and the that we made. I'm gonna click apply. Same message is gonna appear. Yes for all. Okay. Okay, now that we created these planes, we're missing now a different point and a different plane. So still missing points. We're gonna go to create, point, and project. Turn auto execute off. In point list, we're gonna select this point. And in the curve list, we're gonna select this line. We're gonna click apply. And now a point is been made in this curve with this point being symmetrical. Now we're gonna create the plane. So create plane, 3 points. First point is gonna be this point. Get this point, and this point. And I click apply, and a plane is created. We're gonna break the solid again. Edit, solid and break. The solid we're gonna use is this one, and the plane we're using is the plane we just made. We're gonna click apply. Same window is gonna pop up, just for all, and now we made this. Now we're gonna delete the solids that we do not use and also the planes. So we're gonna go to delete solid. We're gonna choose both these top solids that now we don't gonna use. We're gonna click apply, and also delete the planes that we made, since now they're irrelevant, since we're not gonna break anymore the solids. Since we're gonna choose multiple planes, turn the plus signs now. Here we're gonna apply, delete it all. Now we're gonna refill the solid, refit the solid with the bottom part to make a mirror. We're gonna go to edit, solid, and refit. We're gonna leave this all with number 1, 1, 1, and 1. This must go to try CubeNet. Turn auto execute off. And we're gonna select all the 5 solids so they can be able to be meshed. Yes. And yes. Okay, now that we've done that, let's see if all the solids are changed to a blue color. This is the thing you want. You can display the points. everything here. Okay, we're gonna mirror our solids now. So we're gonna go to still in geometry, transform, solid and mirror. Turn out execute off. We're gonna choose all of solids. And in coordinate, I didn't, sorry, I choose different one instead of mirror. Okay, turn out execute off, solid list, choose all the solids. And in the mirror that we're gonna use, we're gonna choose this part, which says 3 points for the plane. And we're gonna choose these 3 points, which is 1, change the plus sign, 2, and 3 points for the mirror. Wait, 1, 2, and 3, yeah. Okay, now that we choose our plane, we're gonna click apply. Says yes for all. Okay, now the other part of our solid is created. We're gonna go and create our group hex 20 and copy the geometry into it. Gonna go to group, create. We're gonna enter hex 20 into new group. We're gonna go click apply and cancel. Gonna go to transform, solid, and translate into geometry. Transform, solid, and translate. We're gonna choose all of our solids so we've created. We're gonna change our direction vectors to space 15, space 0, space 0. I'm gonna click apply. And if a window pop up, you only click on yes. Now that we created our this group, we're gonna go to create the group post, and we're gonna select all. We're gonna click apply, and now we can see all of our bodies, geometries are showing up, all 4 groups. Now we're gonna create a coordinate system. You're gonna go to geometry. Geometry, create and coordinate 3 points. Create coordinate in 3 points. And we're gonna turn auto execute off. We're gonna erase this part. In origin, we're gonna choose, let me change the view so we can see better. We're gonna go in the hex 4, hex 8, sorry, and we're gonna choose this specific points. So the origin is gonna be this point 104. Our axis 3 is gonna be this point 105, and our plane 1, 2, 3 is 146. We're gonna click apply, and now our coordinate system is created. I missed a step here. We must change the type to cylindrical. Click apply again. Now the one is made. And I go to delete, coordinate. Gonna delete both just to be sure that I make a good one. Cylindrical, apply. Okay, now we're good. Okay, now we're gonna mesh our models. We're gonna go to group, post, and hex 8 just to be sure that we're gonna using only this one. Group cancel, applying cancel, gonna mesh, create mesh, and solid. Here we're gonna use hex 8 ISO mesh in the measure, and we're gonna select the solid list that we have, which is our of all solids. We're gonna leave the automatic calculation on since we're using the pattern center edition. If we don't use the automatic calculations, there might be some errors in the part of analysis. So we're gonna leave this on. If you're using the pattern the complete version, you can lower the values to have a more exact value of the analysis and the results. But in this case, we're using the automatic calculation, which is fine for what we're using now. We're gonna click apply, and we're gonna do the same for all the other groups. Post, I'm gonna select all, and we're gonna mesh each one of them. Cancel. Hex 20, hex 20 is this model. Using all, leave automatic completion on. I'm gonna click apply. TET 10, which is this model. Click apply. Mesh created, and TET 4, this model. Click apply. Okay, now that we have our solids meshed, we can observe the element free edges and meshes and meshed solids. We're gonna go to groups. Oh, still we already have all of our groups visualized. We're gonna go to elements, still here mesh. We're gonna go to verify, element and boundaries. We only click apply. This is gonna happen. The elements and boundaries are gonna be verified as it says. Now we're gonna make some equivalences. So we're gonna go to equivalence, all and tolerance cube. We're gonna click apply. Okay, now some vectors are already been equivalized. We're gonna return to verify, element and boundaries, free edges. Gonna click apply and reset our graphics. Okay, now that we have our mesh, we're gonna copy the coordinate system we made in hex 8 to all of our other elements. So we just go to again to geometry. We're gonna go to transform, coordinate, and translate. First, we're gonna enter the direction vector, which is 15, 0 space 15 space 0 space 0. Turn out execute off, and we're gonna change the coordinate frame list to 1. We're gonna click apply, and now we have our coordinate list in this body. Now we're gonna change the direction vector to 0 minus 10. space 0. We're gonna click coordinate frame list, coordinate 1. We're gonna click apply. Now I have the bottom one, and in coordinate 2, then click apply. And now we have the coordinate 1, coordinate 2, coordinate 3, and coordinate 4. Okay, now that we created of coordinates, we're gonna create some loads. We're gonna go to smooth and shaded just to see better our models. We're gonna go to fields. We're gonna create a spatial to PLC function. This you're gonna go here. Here's PLC function, I guess. Okay, you clicking on the one, and then you change the method to PCL function and create spatial and PCL function. We're gonna enter a name as sin pressure hex 8 in field name. In this color function, we're gonna type sin R in spaces, and in between those ones, we're gonna choose this independent variable, which is one from C. Sorry for that. We need this comma and sin RT. From this color function and coordinate, we're gonna go to coordinate 1. This erase it, okay. Sin R, both. Sin R. We're gonna check the T. Okay, now this is in our scalar function. We're gonna click apply. And now we're gonna change to hex 20. We're gonna change the coordinate to the one that is in hex 20, which is number 2. We're gonna click apply. Now it made it. And now we're gonna make TED 10 and TED 4. TED 4, which is the coordinate 3. Click apply. We made, and TED 10, which is coordinate 4. Scalar function is still the same for all both, or for all fourth. Click apply, and now we have the fourth of this one's created. Now we're gonna create some loads, which are gonna be pressure. We're gonna load some boundaries conditions. We're gonna create pressure and element uniform. We're gonna enter hex 8, that's our name, first name, hex 8. For the new name, we're gonna go to input properties, to input data, sorry. This window is gonna appear. And we select for hex 8, the one that says hex 8. We're gonna click OK. And we're gonna select the application regions. Since there are multiple, we're gonna click in the plus sign. And for hex 8, we're gonna choose these 4 faces. We're gonna add them and click OK and apply. Now they see the forces acting in those faces. And we're gonna do the same for the 4 elements that we have. Okay, now we're gonna name the one hex 20, input data, hex 20, okay, application region, it's multiple, it's 1, 2, 3, and 4, these 4 faces. add them, okay, and apply. Set 4, input data, click OK. So application and region, and now here there are two faces only. 1, 2, add. Okay, I didn't put this plus sign, so we only add one of the faces. Add the next one, okay, and apply. Input data, tab 10, okay. Change the name, tab 10. Application and region, the one that are at 10. Okay, and apply. Now we have the 4 of our forces, the pressure, and the 4 bodies that we already made. Now we're gonna create some constraints. We're gonna go to create, fill in loads and boundaries, create, displacement, and nodal. This we're gonna put name as constraints. You're gonna go to input data. In translations, we're gonna go 0 space 0 space 0. We're gonna click OK. We're going to select application and regions, and we're gonna click on the surface or face icon, and we're gonna click in all of the faces in the back of the models of each model. We're gonna choose this part, surface or face. This will allow us to choose the face only. Okay, we must click on the plus sign. This. Now we have all, add, okay, and apply. And now the constraint is made. Now we're gonna create the element properties of the material that these solids are gonna be made. So we're gonna go to properties, isotropic, create isotropic and manual input. We're gonna put the name as aluminum. Gonna input properties. Windows wanna show up. Elastic modulus, we're gonna put type 10 E6 in Poisson ratio 0.3. We're gonna click OK and apply. Now we made our metal. Now we're gonna go here in properties, then 3D solid, create 3D and solid. We're gonna go to input properties. We're gonna add the material that we already made, which is aluminum. No, window is not moving. Aluminum, okay. Forget to put this property name, which is gonna be solid. Okay, and select application and regions, and we're gonna select all of our solids. Ooh, sorry, all of our solids. We're gonna add those. Click OK and apply. Now it's been created. Here's looks solid. Now we're gonna check some of the load cases that we already made. Just to be sure, here in load case load, I'm gonna go to show, default, sorry, modify, we're gonna select default, and this window is gonna pop up. And if everything's correct, this must be shown. Displacement, pressure, pressure, pressure in all of the bonds. So we click console, and we're gonna run our analysis. Okay, for running analysis, first we're gonna go to solution type. Linear statistic must be selected. We're gonna go to solution parameters since we need that this analysis but must be made in an XDB format. We're gonna go to results output format. This window is gonna show up, and be sure to XDB and print are selected. Do not move this one. It must be in 1024. We're gonna click OK, OK, and OK. Okay, now that we made this, we're gonna click apply, and Nastran is gonna run. We just leave the Nastran runs so we can access our results later. Wait till it ends. Okay, now that it has ended, we're gonna go to access results, attach XDB format, and result entities, and we're gonna select the available jobs that we have. We're gonna click in select result file, and the one that we made, log, I made it log-1, sorry, but as you name it, you must choose that one. We're gonna click OK and apply. Now that our XDB file is selected, we're gonna go to results, go create, and here now in the formation, we're gonna select displacement translational, and click apply. Now you can see the deformation that it had. Now we're gonna go here and select displacement attributes. We're gonna unselect show title and show maximum label. Unselect those. And we're gonna click apply. Now we're gonna go to plot erase icon. Click, which is, here you're gonna go home. Here it is, plot erase. And we are gonna erase the geometry. And now, okay. You also must remove the show on the form. Hit apply just to see the deformation. Okay, now we're gonna run the same deformation but with a von Mises stress. So we're gonna go to still results, create, and fringe. And we're gonna choose stress tensor, and the quantity is gonna be von Mises. We're gonna click apply, and now we can see the deformation and where is deformed, and the stress that has in each part of the entire model. As you can see, with different types of meshing, there are different type of stresses being active. This is because of the number of triangles being made and how it works with the program. Okay, now we're gonna read and display the analysis results. We're gonna continue with this. We're gonna go to viewport and click modify. We're gonna rename, go to rename. This window is gonna show up. In default viewport, we're gonna rename it as hex 8. It is here. If this doesn't show, put on in rename as hex 8. We're gonna click OK, apply, cancel. We're gonna go to viewport, create, and we're gonna enter a new viewport name as hex 20. Gonna click apply. Now we have a new viewport name as hex 20, as you can see. And we're also gonna do the same for TET4 and TET10. Click apply again. We have now 4 for Windows. Make them a bit smaller. So we can see all of those at the same time. Or we can move it later. Okay, now that we made this, we're gonna go to display, and coordinate frames. You're gonna select on post all. We're gonna click OK. And we're gonna select the hex 820 viewport by clicking on it. Now we're gonna go to group, post, and select the hex 8 icon. Gonna click apply. Now we're in the current with hex 20 viewport. Okay, viewport, post, select hex 20, apply. Hex 8, okay. The one we're looking at. Click apply, group, hex 8, apply. Okay. Okay, now this is everything you must know. We have all of our models, or they are deformed, analyzed, and we can see our results. And this is everything for the workshop number 8. And hope you learned something. And please check out the other workshops. Have a good day. See ya.